Edexcel A-Level Maths, Pure Paper 1, June 2022, question 13. In an arithmetic series, the first term is A and the common difference is D. We need to show that Sn, the sum of the first n terms of the series, is equal to n over 2 times by 2a plus n minus 1 d. So this is just a proof that we need to memorise. So the very first step is to write out the sum of the arithmetic series. So we have that Sn is equal to a, as our first term, plus the second term, which is a plus d, plus the third term, which is a plus another d, so two d's. And this would go all the way up to the last term, which is a plus n minus 1 d. So you've got to be careful here that you put the n minus 1. And this is because if you notice with our first terms, the first term doesn't have any d's in there. So it's 0 d's. The second term has 1d, the third term has 2d's, so the number of d's is always one behind the term. Once we've written this out, we're going to write the same thing underneath, but in reverse. So we've got Sn, but now it's equal to the last term plus the penultimate term, coming all the way down to a plus d plus a at the end. We're now going to add these two lines together. So we're going to have Sn plus Sn, which is equal to 2Sn on the left. And if we look at those first terms there, if we add a to a plus n minus 1d, we'll now have 2a, and we'll still just have that n minus 1d because we're not bringing in any d's from the top row. So far we've got that 2Sn is equal to 2a plus n minus 1d. Now let's look at the next two terms. So a plus d and a plus n minus 2d. So we've got another a plus a to make 2a, and now we've got n minus 2d, add an extra d, so we're going to end up with the same thing, 2a plus n minus 1d. And if we keep doing this all the way down, so we can see again for the last term, again we've got our a plus n minus 1d and an a, adding them together, every single term is going to give us 2a plus n minus 1d. Now remembering our series, we've got n terms here. N terms, they're all exactly the same, so we can say that 2Sn is going to equal n times 2a plus n minus 1d, and then dividing both sides by 2 gives us our result that Sn is equal to n over 2 times 2a plus n minus 1d. For part 2, James saves money over a number of weeks to buy a printer that costs £64. He saves £10 in week 1, £9.20 in week 2, £8.40 in week 3, and so on, so that the weekly amounts he saves form an arithmetic sequence. Given that James takes n weeks to save exactly £64, we need to show that n squared minus 26n plus 160 equals 0. So we've just created that formula for the arithmetic sequence in part 1, so we're going to use that now. And let's see which values we've got to substitute in. So we know that the first term, a, is equal to 10, because that's how much money he saves in week 1. D, the difference is going to be the second term minus the first term, so £9.20 minus 10 is going to equal minus 0.8. And we also know the total. He saves £64, so our Sn is going to equal 64. Substituting these into our formula, we get that 64 equals n over 2 times by 2 times 10 plus n minus 1 times minus 0.8. We've got our n over 2 at the beginning, and both our terms inside the brackets are multiples of 2. So let's cancel those out. So the over 2 bit cancels with the 2 before 10, and it halves the 0.8. So we've now got that 64 equals n times 10 minus 0.4, n minus 1. If we expand the brackets inside the square brackets there, we would have minus 0.4n and plus 0.4 from the minus 0.4 times minus 1. So bringing all that together, we end up with 64 equals n times 10.4, bring in the 10 and the 0.4 together, minus 0.4n. Multiplying through by the n is 64 equals 10.4n minus 0.4n squared. We're now going to bring it all together onto the same side to give us 0.4n squared minus 10.4n plus 64 equals 0. Now we're aiming for a quadratic with no coefficient in front of the n squared. So to do that, we're going to divide through by that 0.4 that we've currently got in front of the n squared. And if we do that, divide every single term by 0.4, we get that n squared minus 26n plus 160 equals 0 as required. For part B, we need to solve the quadratic equation that we've just worked out. Note that this question is only a 1 mark question, so it's not going to be a tricky one. So the very first thing to check is, can we factorise our equation? So we need two numbers that will multiply together to give 160, that will add together to give negative 26. Well, that's going to be negative 10, negative 16. So we have n minus 16 times n minus 10 equals 0. Hence, n must equal 10 or 16. For part C, hence, so using what we've just worked out, we need to state the number of weeks James takes to save enough money to buy the printer and give a brief reason for our answer. So it's either 10 weeks or 16 weeks, based on the answer that we've just worked out. But if we think about applying this to the problem properly, he's saving up to buy a printer. We know that by 10 weeks, he's saved enough. Hence, there's no need to keep on saving to get to 16 weeks. So we're going to say 10 weeks because he has enough by this point, hence doesn't need to keep saving further. The reason we've got 16 as an answer as well, in that after week 10, the savings will go up, but then because he's saving 80p less every week, he'll get to a point where he's saving a negative amount and it will come back down to 64 at 16. So that's why we've got those two different answers in part B. If you've enjoyed this video, remember to subscribe to the Doing Maths channel to keep up to date with all the latest releases.